Completing the square. What is it? How do you do it? In this video, I'm going to explain what it is, and then I'm going to do 3 examples. Completing the square is a little math trick that we are sometimes called upon to do when working with the equations of parabolas. It also works with the equations of circles. Here's a parabola in standard form. Here's another version of that same parabola in factored form. Now in high school algebra you would have learned how to convert back and forth between these two. You convert from factored form to standard form by multiplying out the terms, x times x times -5, -1 times x, and so on. We call that foiling, F-O-I-L, because it stands for first, outside, inside, last. To convert from standard form to factored form, you look at the numbers and essentially it's guess and check. You try to figure out what numbers would make sense over here, and then you fiddle around and you sort it out. It turns out there's another way to write a parabola, and that is in vertex form. And you could convert back and forth between standard form and vertex form. To convert from vertex form to standard form, you would multiply out the terms in this square term and simplify. To convert from standard form to vertex form is what we call completing the square. And this square term right here is the square that we are going to complete. So my first example, I'm going to start with this. I'm going to convert to this, and then I'm going to show how to reverse engineer that process to convert from standard form back to vertex form. And then we'll do that a couple more times. So there's our formula in vertex form, and I'm going to convert to standard form first. So what we do is we multiply out this squared term, x squared minus 6x plus 9 minus 4, and we're almost there. We can combine a couple of terms, basically those two, and that's about it, really. And we get y equals x squared minus 6x plus 5. How do we reverse this? Well, let's write this over here. Y equals x squared minus 6x plus 5. What do we do? Well, let me start out by writing this again. And I'm going to actually write out this and that. And then the plus 5 I'm going to put way over here because I need that space for something. So this second line is so far identical to the first. It just looks a little funny. I'm going to try to figure out what to put into here such that I can make myself a perfect square. And the way to do that is to think about what happened over here. Notice this -3. When we foiled this, we multiplied -3 times x, and we had to do that twice, and that's why we got -6x. But we also squared the -3, and that's how we got that +9. Now, of course, we already know what our answer is going to be over here, but if you didn't know that, you could reason out what to put in here by following this logic. Notice that this -6 here is equal to -3 times 2. So if I divide this -6 by 2, I'm going to get the -3 that I know belongs in there, and I know if I square this, I'm going to get this +9. And the way that looks is basically -6 divided by 2 is -3, and then if I multiply -3 times itself, -3 squared is +9. So I need a +9 over there in order to make a perfect square. But of course you can't just go willy-nilly adding numbers into equations, because what I have written here now is different from what I had in the previous line. So to make it all make sense, I'm going to put in a -9. So I have +9 minus 9, which of course cancels out, so there's now no real difference between this and the previous. But you can see now that these 3 terms make a perfect square. So I'm going to write out what that perfect square is. Should be pretty easy to see that x squared minus 6x plus 9 is x minus 3 squared. And then I'm going to put together everything I have left over, the -9 and the +5, and that makes for a negative 4. So here we have another example. We're going to convert this into vertex form, but this time we don't know what the answer is, so we have to figure it out. Let's start by writing out this stuff again. I'm going to leave myself a space there. And now we need to figure out what goes into this space. Now, whatever my perfect square is, it's going to involve a number that's half of that. It's going to involve 3 halves. That number added to itself equals 3, and then that number is also going to be squared. And what we end up with is we have 3 halves. We're going to square that, and that's going to get us 9/4. It's a rather awkward number, but we're kind of stuck with it. So I'm going to add 9/4 and then subtract 9/4. And what we have now is some numbers that put together make a perfect square, and then we have some stuff left over. What do we get? Well, we get x plus 3 halves squared. You can see that 3 halves times x plus 3 halves times x makes 3x. 3 halves squared makes 9/4. And then all that junk left over makes whatever number it is. Negative 9/4, 2 is equal to 8/4. So I guess that would be negative 1/4. So this was not quite as simple as the last example because we had this half involved, which then made for a fourth. And that's just something that's going to happen whenever you have an odd number times x. And it's awkward, but it's certainly manageable. So here's another example with a new twist. We now have a coefficient in front of the x squared. And that makes things awkward. Anytime you have a number in front of the x squared, or even just a negative sign by itself, you have to do some extra work. And there's more than one way to come at this, but I think the most straightforward way is to simply factor out a negative 2 out of everything. So we'll have an x squared. 6 divided by negative 2 is actually going to get us a negative 3. And then 1 divided by negative 2 is kind of strange, negative 1/2. So now what we have inside the green brackets is essentially the same thing we've seen already. So what I recommend is once you factor this number out, just disregard it. Do this, and then at the end, multiply everything times negative 2. So that's what I'm going to do now. So let's see here. We have x squared, negative 3x. Going to have the minus 1/2 over here. And once again, we have a 3 halves. So we're stuck with this negative 3 divided by 2. And then we're going to square that. Gets us another 9/4. So I'm going to do plus 9/4 minus 9/4, just like before. And again, we have a perfect square with some stuff left over. So this perfect square is going to get us x minus 3 halves squared. You can see that negative 3 halves times 2 is negative 3. Negative 3 halves squared is positive 9/4. And then this junk left over gets us whatever that is. 1/2 is 2/4, and I believe we're looking at minus 11/4. Now, of course, we can't forget about this negative 2. So in the very last line, I guess I'll put these brackets back in here and put the minus 2 there. And now I'm going to multiply negative 2 times everything. And that'll get us our final answer. So negative 2 times x minus 3 halves squared. Negative 2 times negative 11/4 is going to give you positive 11 halves. And there is your answer right there. If I were doing this problem myself, this is exactly how I would do it. Technically, this is not quite right because I left some stuff out. If you were doing this yourself, I would recommend doing this, but if you were going to turn in this problem and someone was going to grade you on your work, then I would not turn it in like this. Honestly, I would just go back after the fact and just fill in all this stuff. And there you go. They can't fault you on that. That's exactly right. Of course, technically, you're supposed to keep all of this stuff, the minus 2 and all that, and write that over and over as you go. think that's kind of a distraction, gets in the way of the real challenge, which is focusing on this completing the square stuff. Whichever way you like to do it, whether you want to be complete each line as you go, or whether you want to divide and conquer and just focus on parts of equations, there's something to be said for both approaches. Now, a lot of people struggle with completing the square. The good thing about it is once you get the hang of it, it's actually pretty easy. It's actually easier than factoring because there is no guess and check. Every time you do it, you just zero in on that number in front of the x, you divide it by 2, and you square it.